Hello, welcome back to the Subscribe blog. It is 2013 now, so I wish you a happy new year. I wish you prosperity and health, and that all your wishes come true, obviously. You'll notice that there's a change of scenery. This is the Redmond main campus, and we're looking at the main campus sports fields. And you also might notice that the Pacific Northwest is not disappointing, and it's keeping to its reputation of being a very rainy place at this time of the year. So it's raining. Not that Europe would be a lot better, where I'm from. This is kind of home weather for me. And so during this time, during the 2 weeks that I'm here, I also hope that I can get some of my colleagues in front of the camera, so we can talk about whatever's going on in the team, whatever we're planning, and also some foundational things. I have talked to my test manager, and my test manager is very open to talking about some principles of test, and also why it's worth having a dedicated test team on staff if you're building sophisticated large systems. So that's as much as a forward-looking thing to what might happen this and next week on the blog. You'll also notice that I'm wearing a jacket, and that's because the topic I want to talk about today is serious business. It's about transactions. Transactions is a topic that has been flaring up on Twitter in the last several days, and I also hear quite a bit about transactions from customers who say, how does that work in the cloud? Is it the same? Can I just use the same kind of techniques and technologies? And people who are running into problems with that. So we're going to talk about transactions kind of during, or I will talk about that, and probably talk about it also with some colleagues here. We'll talk about that over the next several weeks, and what I want to do today is I want to level set and talk about some foundational principles of transactions. So to talk about transactions, I have here Will Perry. We're actually not going to talk about transactions, but we're going to do a little bit of play. So I'm going to, I want to buy your phone.
Okay, what are you going to offer me?
You have a wonderful iPhone 5, I see, and I want to offer you $1.
It's going to cost you more than that, Clemens.
Good. Let me go and edit that and make an annotation here. I'm going to offer you $100.
Getting closer. Yeah, all right.
Okay, so I know I offer you $100, and I know where your car is.
All right, I'll take the money, Clemens. Just leave my car alone.
Good. So let me put that away. So here's the money.
Lovely, thanks.
That was not what I had in mind. Actually, come back. Thank you. So since I obviously can't trust you in doing this right, let me get a trusted third party into the picture. Abhishek, if you would. Thank you.
Hi. So
Abhishek is going to be our trusted third party in this transaction. So we now negotiated. I sufficiently cried about having all these children I need to support, etc. Therefore, I can't pay more for the phone. And so now we're going to do that transaction, but we're going to do that in a way that Will can't cheat. So I'm going to give you the money.
And I'll give you the phone.
Yes.
Step 2.
Yes. And now yes.
Step 3.
Step 3. Step 4. Now I have
I'm done.
The wonderful phone.
And I have the wonderful money.
He has the wonderful money. Now he's going to do something completely outrageous. He will destroy the money. Which means that now the transaction completed, but he actually obliterated the results on his side, which is fairly stupid. But I told him so. That's not his fault. So I'm gonna take that as an example, and as I go on the whiteboard, and I'll talk about all the things that we've seen just now. So thank you to Will and Abhishek for helping me with a little play. Before we even get to that transaction with the phone, something else happened. So let me start with that and then come back to what you just saw. And I'm going to start with a very simple transaction. That is one. The wallet contains, let's say, $35. And now the hand contains $1. So I made a debit on the wallet, and I put this into my hand. Now the hand is not a really permanent resting place for money. So let's go and make this, let's take the hand that takes the role kind of the transaction, the in-flight transaction, the code, if you will. So I'm going to put this into my pocket. I did a local transaction. The local transaction is on me. It's a trusted system, right? There's no risk of failure because of wrongdoing by anybody else, and there's no trust issues that are here. So that's something that's fairly easy to do, but it's still, there could still be errors. So I just take this out of my pocket again and I put this in here. Let's go and take this out, put this in the pocket up here. Well, that actually doesn't work because that's closed, as it is with jackets often. So I don't use that front pocket. So I can't put that in here. I can't complete the transaction, so I have to go and put this back and do a rollback. So there's two places, two accounts, if you will. There's an account that's my wallet, that's the account that is my pocket. And since the pocket won't accept the booking record, if you will, the banknote, I have to undo the other operation. That is talking about atomicity. Atomicity meaning of the asset properties in transaction. Atomicity meaning either if you're doing a transaction, if you move things from one place to the next place, if you have two or more resources in play, then the operations on all of them need to succeed, or they will all fail, or at least one fails, and then the other ones need to be put back into their previous state. So that's what I'm doing with this, is can't put that in here, gotta go and put that back here. Consistency means that in the case of a failure, if that doesn't work, I neither lose the dollar, nor I produce another one. If I could spontaneously produce, because of a failure, a second dollar, that would be beautiful, and I would certainly keep that to myself, and I would better have to keep that to myself because that would be illegal to create money that way. So consistency means that as I do this, as I succeed or fail, I must stay consistent. I can't kind of create or delete or destroy data as I do this. Isolation means, there's another property here, that let's create some concurrency, even though it's a little contrived. I'm taking the money out of my wallet, and I keep that in my hand. $34 are now in the wallet. But that's not done yet, because it's on the way to this pocket. Now there's a concurrent operation happening where I want to go and spend $35 on something. So probably my wife comes along and says, hey, I need to have $35, and peers into my wallet and wants to take that money out. Is that okay? Can she take the $35 out? Well, there's a transaction in flight. The operation will succeed if this fails and I put the money back, because then there's still $35. If this succeeds here, then it's going to be short. So, and she will have to go and look for money elsewhere. So it's one operation depends on the other operation, and isolation deals with that. Isolation specifically deals with concurrency. If you have multiple operations happening at the same time, and one depends on the other, or you are observing, you're looking at shared resources, and you have overlapping transactions happening, what can you see, what can't you see, is subject to, and that's a matter of isolation. Isolation is also the piece, the concurrency aspect of this is the piece that actually causes the most constraints on the system, because it requires that you lock things. One thing you want to prevent is if you're reading a result, so you're starting a transaction and you're doing select operation on the database. There's an overlapping transaction that happens. That is, your transaction is this. Let's go and put this in a picture quickly, right here. You have a transaction that you start, and you start reading data here. Another transaction starts, and that inserts a record into your database, and now you read data here. This result and this result, now you need to decide whether this result can be affected by this one, or it won't be affected by this one. Whether you are actually here operating on the effectively creating a snapshot of your data and operating on the same snapshot where you want to have the same view that you had before this happened, since your transaction here is still pending, or whether you're actually okay with having intermediate results kind of injected into your in-progress transaction. This is what all these isolation modes of databases are about, and we're not going to go into more detail on that at all. But all of those things that I just talked about are local concerns. So atomicity, consistency, isolation are local concerns. The fourth one here, durability, is about what happens with the result. So I have some money. I actually have my pocket has an extra $1. So I'm going to put that $1 into my pocket now. I have 36. So now it's a durable result. This is it's an irreversible thing that just happened. It's permanent. Of course, it's not. This $1 will not stay permanently in my pocket. What this means is that once the transaction commits, once it's over, and I leave my hands off, now anybody peering into my wallet will actually see that money being there. That's what that means. It means the operation is done. There's no doubt that it's done, and it's over. It's durable. It's final. That's what that means. It doesn't mean durable into all time, because ultimately, as someone on Twitter mentioned, the sun will explode, so nothing is really forever permanent. So durability really would be better named published or done or final. But they choose durable because durable means it actually sits on disk. It's not cached, it sits on disk because it's a database terminology. But in today's day and age, where we have databases that are sitting in memory or other transaction participants which live in memory, it's a little bit of a dicey term, because not everything is really durable in the sense of durable on disk. But if a database is fully in memory, durable really means the data is in the same place as all the other data. It's published, it's made available, but the same means that all the other data is made available. That's mostly what that means. What we saw earlier with the transaction, one with Will directly and the other one held by Abhishek, was a distributed transaction. A local concern was me taking the money out of the pocket and making that available to Will and Abhishek. And another local transaction was Will reaching into his pocket and taking his iPhone out. And then we did the exchange. We did a transaction. I did a transaction with Abhishek, and Will did a transaction with Abhishek to give him both of the assets. And then Abhishek did a swap and another transaction to give us the data, or to give us the goods in that case. But that served purely to satisfy one of the properties. It was there to satisfy A, that the trade that we did either goes through or doesn't go through. Abhishek ended up, after Will chose to bail in the first one and I no longer could trust him, I enlisted a trusted third party, a judge effectively, on the outcome of that transaction. So he acted as the coordinator. And the coordinator, Abhishek, the atomicity man, Abhishek guaranteed that the operation succeeded completely or failed completely. So if I had given Abhishek the money and Will would have refused to give him the phone, then Abhishek would have returned the money to me. The coordinator doesn't care about consistency and isolation and durability. The coordinator trusts the enlisted parties to actually create those assurances. That's what the protocol does. The protocol is executing here between the coordinator and the resource managers is effectively just a way of promising the outcome of the transaction and guaranteeing the atomicity of it and the succeed together, fail together of it. But it's not about any of the other properties, not about any of the other things. These are purely local concerns. So we actually have two terms that have to do with transactions that are kind of very close together, and often are thrown into the same bucket, but are really separate. There's a distributed piece, distributed transaction, which talks only about atomicity, about fail together, succeed together. And whether the data is, in the end, durable, sits on disk, sits in memory, or is basically just, a light flashes on a building, that's fine, right? It's not of the concern for the distributed transaction. The key concern here is that if I initiate an operation, and there's another operation that needs to happen because of it, that both happen, or both fail, or if one fails, then the other one can be undone and is not final. Everything else is a concern of the local resource. So two things, as I said, two things in transaction. There's a local set of local concerns which have to do with the database. And so if you talk database transactions, talk about all those properties and the necessary precautions, locks, isolation, etc. And then creating atomicity around those things. Now, creating ACID around a larger system, and we have increasingly federated systems, is an enormously difficult thing. So transactions, as we know them, are actually very good, or they're still very suitable, as long as you're looking at a local resource, as you're looking at one consistent set of data, let's say, a particular database. We have a number of rows, the rows belong together, you have a relational model. That's where transactions and the ACID model are still make a lot of sense. But when you think about the problem of the problem of isolation, and really doing what I just said here, and have a result that you have recovered here at point in time 1, and there's a point in time 2, and let's say there's a minute or 2 minutes between those points in time, and there's things that are happening in the middle. If you think about a large distributed system with very many resources, very many databases, very many actors, you can't guarantee isolation because you have very many data sources which might be volatile. And it's impossible to go and create a lock around all those things because you're going to lock the world, and you will prevent changes. So distributed kind of cross-system ACID isolation is fairly impossible to do. So what we see people do instead is rely on lesser guarantees and on eventual consistency, and lessen the reliance on the absolute consistency that's nearly absolute consistency that's given to them by the classic transaction model, and also lessen the reliance on things like isolation, and really are moving to a model that's more suitable for either large distributed systems with multiple resources with many participants, and also where operations take a very long time. So they don't rely on the classic transaction model on the ACID properties anymore. Instead, there's an antonym for ACID. It's called BASE. Stands for basically available soft state and eventual consistency. And they're not as closely related as the ACID properties are, but it's a nice antonym to create. And that's about creating systems that are more relaxed on their resources, but not less mission critical, but they achieve their transactional consistency through somewhat other means. So I'll be talking about those things kind of in the next several weeks. I'll be talking about how you can use messaging to replace these coordinated transactions, creating atomicity around multiple operations in this way, in a synchronous fashion, by using asynchronous messaging, and how to pair the classic transaction model, which is still useful and valuable around individual databases, and which also Service Bus, for instance, gives you. We have a local transaction model around individual entities. I can use that and pair that with other ways to create that consistency, and also can pair this with models around compensation, where you actually do some work and realize that work, and once you find that the work can't stand that way, you made a hotel reservation, then you have to cancel that hotel reservation, something that people do all the time. that he can go and back those things out and then do the right thing with forward progress. There's some mechanisms for this, and I'm going to be talking about them in future episodes here on the blog, and also have some talks with some other folks here on the team and some other teams, and some folks from the community, hopefully, around those topics, because transactions is something that's kind of the evergreen in business software. So thank you for paying attention and for staying with me for so long, and I'm looking forward to welcoming you to the next episode.